Welcome to Factory Discovery. Today, we'll know about how defense fighter jets are made. The secret journey of a modern war machine. Introduction. Do you know how a modern defense fighter jet is actually made? Not a passenger airplane that carries travelers across countries, but a machine designed to fly faster than sound, perform extreme maneuvers, detect threats from miles away, and protect an entire nation. Every fighter jet begins as nothing more than raw metal, carbon fiber sheets, titanium blocks, wires, and thousands of separate components scattered across a factory floor. Yet over time, these ordinary materials are transformed into one of the most advanced machines ever created by humans. The process requires extraordinary engineering, cutting-edge technology, and thousands of skilled workers. A single mistake can cost millions of dollars, while a single improvement can save lives. Today, we are stepping inside the fascinating world of fighter jet manufacturing to uncover how these incredible aircraft are built, tested, and prepared for the skies. By the end of this journey, you'll understand why fighter jets represent some of the most complex engineering projects on Earth. Part 1. Building the foundation of a Sky Warrior. Every fighter jet starts long before assembly begins. Inside specialized aerospace facilities, engineers carefully select materials capable of surviving some of the harshest conditions imaginable. During flight, fighter jets experience extreme temperatures, powerful vibrations, high-speed airflow, and intense G-forces. Ordinary materials simply cannot survive these conditions. That's why manufacturers rely on advanced aluminum alloys, aerospace-grade titanium, and carbon fiber composites. These materials combine incredible strength with low weight, allowing the aircraft to remain agile while carrying sophisticated systems and equipment. Massive sheets of metal and composite materials arrive at the factory and immediately undergo inspection. Engineers verify dimensions, strength, and quality before production begins. Once approved, the materials move to highly advanced machining centers where computer-controlled equipment cuts, shapes, and drills components with astonishing precision. Some parts must be accurate to fractions of a millimeter. Robotic arms work continuously, carving complex shapes from solid blocks of titanium while sparks illuminate the production floor. Nearby, giant composite panels are formed inside specialized environments where temperature and humidity are carefully controlled. As hundreds of individual components are completed, workers organize them according to detailed production plans. What appears to be a collection of random random parts is actually the beginning of something extraordinary. Each piece has a specific role in the future aircraft. Every bracket, panel, support frame, and structural component has been engineered to contribute to the fighter jet's strength, performance, and survivability. Slowly, the foundation of a modern air combat machine begins to emerge. Part 2. Assembling the aircraft skeleton. Once the individual components are manufactured, the assembly process begins. Large fuselage sections arrive at dedicated assembly stations where engineers carefully position them using advanced laser-guided systems. This stage resembles building a giant three-dimensional puzzle, except every piece must fit perfectly. Even the smallest alignment error could affect performance later in the aircraft's life. Workers secure structural frames, wing sections, and internal support components, while sophisticated measurement systems continuously verify accuracy. As assembly progresses, the aircraft gradually takes shape. The long fuselage becomes recognizable. Wings are attached. Internal compartments begin forming. Specialized reinforcement structures are installed throughout the airframe to handle extreme stresses encountered during flight. Unlike commercial aircraft, fighter jets are designed to perform aggressive maneuvers that place enormous loads on the structure. Every connection must withstand these forces repeatedly without failure. Engineers inspect every stage of construction. Measurements are checked and rechecked. Digital records document every installation. Quality control teams examine structural joints using advanced inspection techniques. The process may appear slow, but precision is essential. The aircraft being assembled today may one day fly missions where reliability means the difference between success and failure. As the skeleton grows stronger and more complete, the fighter jet starts to resemble the powerful machine it will eventually become. Yet despite its impressive appearance, it remains an empty shell waiting for the systems that will bring it to life. Part 3. Installing the aircraft's brain and nervous system. With the structural assembly complete, technicians begin one of the most complex stages of production. Modern fighter jets rely on thousands of electronic systems working together simultaneously. Hidden behind panels and beneath the aircraft's skin lies a vast network of wiring, computers, sensors, communication systems, navigation equipment, and flight control technology. If the airframe is the body, these systems form the aircraft's brain and nervous system. Technicians carefully route miles of wiring throughout the aircraft. Every cable follows a predetermined path designed to maximize efficiency and reliability. Thousands of electrical connections are installed, tested, and documented. Advanced computers responsible for flight control, navigation, and mission management are integrated into dedicated compartments. Sensors capable of monitoring everything from engine performance to environmental conditions are positioned throughout the aircraft. The complexity is astonishing. Modern fighter jets process enormous amounts of information every second. Radar systems detect objects at great distances. Navigation computers continuously calculate position and movement. Flight control systems monitor aircraft behavior and help maintain stability during demanding maneuvers. Communication systems allow pilots to coordinate with other aircraft and command centers. Every component must function flawlessly. As installation continues, the once empty airframe begins developing intelligence. Systems are powered for the first time. Engineers conduct diagnostic tests. Screens illuminate. Computers exchange data. Gradually, the fighter jet starts to awaken. Yet one crucial element remains missing. The aircraft has a body. It has a brain. But it still lacks the heart that will propel it through the sky. The engine installation phase is approaching, and this is where manufacturing enters an entirely new level of engineering complexity. Part 4. The engine that defies physics. A fighter jet can possess the strongest airframe, the most advanced electronics, and the most sophisticated sensors in the world, but without its engine, it remains nothing more than an expensive collection of parts. The engine is the heart of the aircraft, and building it is one of the most challenging engineering tasks in modern manufacturing. Inside specialized facilities, engineers assemble thousands of precision machine components into a machine capable of generating extraordinary amounts of thrust. Unlike commercial aircraft engines that prioritize efficiency, fighter jet engines are designed for extreme performance. They must accelerate rapidly, operate at intense temperatures, and provide the power needed for supersonic flight. The process begins with turbine blades manufactured from advanced superalloys capable of surviving temperatures hot enough to melt ordinary metals. These blades are shaped with incredible precision because even microscopic imperfections can affect performance. Engineers carefully assemble compressor sections, combustion chambers, turbine stages, and afterburner systems. Every component is inspected repeatedly before installation. Once assembled, the engine undergoes rigorous testing on specialized test stands where engineers simulate real operating conditions. The roar produced during these tests can be heard for miles. Temperatures soar, pressures rise, and sensors collect enormous amounts of data. Only engines that meet strict performance standards are approved for installation. When the completed engine finally arrives at the assembly line,